Hello, welcome to Weatherwise. I'm your host, meteorologist Nathan Scott. It is summertime here in the Northern Hemisphere, and in Arkansas, usually we talk about conditions hot, humid, and hazy. But sometimes the haziness is not always due to so much humidity in the atmosphere. There are different reasons behind the haze that we see here in the natural state. One of those reasons could be potential wildfire smoke arriving from Canada or maybe the western parts of the country. And then another reason is, believe it or not, dust from the Sahara making its way in here from Africa, traveling 4,000 miles all the way to North America. Let me give you a perspective on what our typical sky looks like here in summer. So this is from our Simmons Bank camera. It's about 500 feet above the surface, and it's a clear sky. The visibility looks pretty good, and you can see that because you've got the mountains way in the distance. We can see Pinnacle Mountain. We can even see Rattlesnake Ridge on this date. This was August of last year, August 1st, but what happens when you have a plume of dust from the Sahara, it really reduces that visibility dramatically. This was a thick layer of dust that happened last year, and we have lost the view of the mountains. You can't see Rattlesnake Ridge or even Pinnacle Mountain from this photo. The dust can also reduce air quality, but typically this dust is about 5,000, maybe 15,000 feet. So how does the dust from the Sahara Desert, which is located in North Africa, make its way all the way to North America? Well, it all has to do with the weather pattern and how the winds flow in certain parts across the world. So here's the Saharan Desert. It's including Algeria, Libya, Egypt, and then also Sudan, all the way to Mauritania, Morocco. And then you have the equator. And these arrows represent the surface winds. So below the equator, we've got the winds coming in from the southeast. Above the equator, we've got the winds coming in from the north and northeast. And these are known as the trade winds, the winds that go from the west or from the east and push off to the west. Dust from the Saharan Desert makes its way into the atmosphere because of storms. Storms bubble up, and as the storms collapse, just like what we talk about here in Arkansas, you get that outflow boundary. You get that gust of wind. And that gust of wind will pick up the dust or little sand particles from the Saharan Desert, and it will actually send it well up into the atmosphere, like I said, 5, maybe as high as 15 or 20,000 feet. And then the winds, the trade winds, will take that dust, because of course it's very light, and it will send it across the central Atlantic. And that plume of dust will continue to make its way through the Caribbean Sea and eventually even into North America because of this feature, this surface feature known as the Bermuda High, which is very common to see in the summer season. This is the reason behind the direction of the winds going from the east off to the west. This Bermuda High also not only steers where the dust goes, but also controls where a tropical storm or hurricane may travel, because if the high is more situated closer to the east coast, it's going to keep a lot of the tropical activity aimed into the Gulf or over into Central America. But if that high, say, is a little bit farther off to the east, that could allow the door to be open to have a tropical storm make its way along the east coast. Dust from the Sahara is very important to the Amazon rainforest and into northern areas of Central or South America and also into the Caribbean. The dust provides the rainforest, the plants, with valuable minerals, and it also includes valuable minerals that will be very beneficial to the coral reefs across this part of the world. So it's a necessary thing to have, and your dust also cuts down on the potential of tropical activity, because when you have dust, you've got a lot of dry air in place, and tropical storms and hurricanes need a lot of moisture. So they don't like to have dry air in place. But there you see the dust continues to push its way towards Texas, and eventually it can take its time and make its way across a large part of North America, but the concentration of the dust will be much lower say in the northern plains versus along the Gulf Coast. This is a forecast model from July 28th. The highest concentration of dust, according to this forecast model, is over Libya, Algeria, and also into West Africa. There's the high pressure. You see the winds pushing that dust across Africa, into the Atlantic, across the Caribbean. I went to St. Lucia on my honeymoon, and it was in June, and there was quite a bit of dust that made its way across the islands, and that kind of ruined a little bit of the viewing for that tropical looking sky. One day it was a beautiful blue sky. The next day it was much more muted, gray. And unfortunately, I wanted to check out the sunset, but the dust was so thick that before the sun reached the waterline or the horizon, it disappeared. It was that thick dust. And that tells you that was a very high concentration for that to happen. But according to this forecast model, we even have a little bit of dust moving into Texas and all the way up into Iowa and Indiana that may make the sky a little bit more muted, maybe a little milky gray, depending upon how much concentration there is with this dust, but it's on the low end, so really not a big deal. The dust in the atmosphere can make for some really vivid sunrises or sunsets. You may have seen this before. When you look outside just before sunset, you notice the sun is really red. Unusual for it to be so red. Well, it's all because of the dust. The dust actually interacts with the waves of the sun to produce that effect. I'll explain why that's the case in just one second, but here's your comparison of a dusty sunset versus a normal sunset. So there's your clear sky, no dust, bright sun, a typical sunset. But when you have a dusty sky and that plume of dust and all those particles around, that is going to give you a muted color, but also you get more of a orange-red or a more red sunset and sunrise that happens. What is the reason behind this? Well, it all has to do with pretty much light physics. We break down your light spectrum. You've heard of Roy G. Biv. What are rainbows made of? Red, orange, yellow, green, blue, indigo, violet. When we take a look at the actual lengths of the waves of each color, they are different. Your wavelengths of blue and violet are shorter compared to what you see here with the red. So as a normal sunset produces a orange sunset or a orange sunrise, it's all because you as the viewer is looking through a lot more stuff, a lot more atmosphere with your perspective on as the sun begins to rise or set. That sunlight has to go through a lot more stuff, a lot more molecules, and your blues and your greens and your violets all get scattered out. So you're left with the orange and red look to the sun. When you have a plume of dust in place, that is even more stuff that the sunlight has to go through to reach your eyes. So therefore, pretty much you only have the red colors that make its way all the way to your eyes because all the other colors are scattered out. We love to get your pictures of sunsets, but any weather phenomenon. One of the best ways to do that is go ahead and text your photos to us. 501-376-1111. You should have that number saved in your phone if you already don't. And also another group that you may be interested here, it's a Facebook group. So if you have Facebook, go ahead and type in THV 11 Weather Reporters. And this is all Arkansans coming together, just sharing different types of weather photos like this one with the lightning. You do have to be pretty much admitted into the group because we want to make sure we keep out all the spam and other junk that can happen sometimes on Facebook. Coming up next, we're in the dog days of summer, but it has nothing to do with Fido. It actually has to do what's happening in the night sky. Stay tuned. I'm sure you've heard of the term, it's the dog days of summer, which typically means it's brutally hot out there. But this saying has originated from ancient cultures, and it has to do with a constellation that happens in the nighttime sky, which is actually a winter constellation. We see this all the time during the winter months, but this constellation is just beginning to rise, getting into the latter parts of the summer months. So officially the dog days of summer, July 3rd through August 11th. And ancient cultures, like the Egyptians, looked for the bright star of Sirius. And you can't miss this star because it's actually the brightest object in the sky versus the moon. Again, it's a winter constellation, and it actually will change colors due to its twinkling nature. But this is all part of the constellation known as Canis Major, or pretty much it's simplified as the big dog. And this is actually in the mythology the hunting dog of Orion the hunter, which Orion would be a little bit higher in the sky here. But when the Egyptians saw Sirius rise above the horizon, that would signify that weather changes were about to take place. And they were excited about this because most likely they were dealing with a drought, but when they saw Sirius begin to rise in the nighttime sky, that meant the season is about to change, and more than likely, rain would start to arrive and flood the Nile River, which would provide crops with fertile soil, and therefore things would really change in their lifestyle after dealing with drought for a few months. Hopefully they were going to get some really good crop growth and be able to feast once again. The Egyptians were not the only ones watching this, though. Also, the Greeks were watching this as well. And they saw it as a sign of bad weather was coming, that there was going to be storms or maybe a drought developing. So they call it the dog star because it's linked to Canis Major, the constellation, and that's why it's known as the dog days of summer. Also, when you think about constellations, the constellations all revolve around the North Star with Polaris, which of course is in the north part of the sky. Everything revolves around Polaris, and we call it the celestial sphere. So right now, you can't see this constellation in August until maybe possibly just before sunrise. But then as we continue to go through the fall months, this constellation will begin to show up higher and higher in the eastern part of the sky, and eventually you'll see it all night long once we get into the months of November, December, and of course January. Now the dog days of summer are linked to, like I said, the hottest temperatures that we usually see here in the United States, in Arkansas, and this is the meteorological summer data. So there you see our highest average high is 93 degrees, and it happens August 1st, and then we start to back down. So it's very fitting. Dog days of summer linked to extreme heat. You see June 30th, 90, and then by August 31st, our average high drops down to 89. 100 degree days. We have not reached 100 degrees as of yet. This was recorded on July 28th. We've gotten close. We got to 99. But last year we had 7, and the first time was July 3rd. 2023, it was 15. 2022, it was 18 days. 2021, just 1 day. And we did not hit 100 for 2020 or 2019. But look what happened in 2012. We had 29 days of 100-degree heat. So, yeah, dog days this summer. Next time you hear that term, you have to tell your friends and family. It has nothing to do technically with the heat. It all has to do with the constellation known as Canis Major and the dog star Sirius that signified to ancient cultures changes were about to happen, and the season was about to go from summer eventually into fall, and then of course winter. Next, we're going to talk about some changes that have been happening at the local National Weather Service at Little Rock, which does impact meteorologists and also you at home. Before we close out weather-wise, I want to let you know that they have had some changes at our local National Weather Service. And this is from really July 13th due to budget cuts that we are seeing across the country with the National Weather Service and the Department of Commerce. We're starting to see some changes here locally. And the first one that stands out is the upper air balloon launches, which usually happen 12Z and 0Z. This is universal time code. So basically for this time of year, they launch the weather balloons at 7 o'clock in the morning and 7 o'clock in the evening. That's 12Z and also 0Z. So 12Z, 7 o'clock in the morning, 0Z, 7 o'clock in the evening. They want to change it to 6Z, and they did make some changes to 6Z. The problem with that is the data that you get in the middle of the night, real-time data of what's happening, not only at the surface, but from the surface up into the upper parts of the atmosphere is very critical. And when you get that data during the middle of the night, it can be much different than what you get right around sunrise. Now, as of right now, schedule changes have been made to go ahead and change it back to 12Z. So we'll see if this continues to be the case. Hopefully it will, but the National Weather Service, I've got friends over there, they have told me that it's a little bit of a struggle. There have been schedule changes and they are running on a low staff because a lot of people took the retirement packages that were available earlier this year by President Trump administration, and there's laws that went into effect. Public outreach. This is another thing that the National Weather Service has done year after year. As of right now, hopefully this is temporary. All events have been canceled that involve anything with the public. That does include the Skywarn Spotter program. And these are very important classes because this is when you go to a class and you learn about how to spot wall clouds and how to spot scud clouds and what's the difference in a wall cloud and a scud cloud. And they're really good at really talking about what you as the viewer can expect when there's a cloud that shows up in your neighborhood and you're not sure if it's a tornado, if it's a funnel cloud, if it's something you should be concerned about, if it's not something you should be concerned about. They really break things down very easily with these classes, and it's very important to have Skywarn spotters to relay information to the National Weather Service when the weather turns severe or when there's just some rain or snow that they want to know about. So hopefully this is temporary, but as of right now, all the classes have been canceled until further notice. Other things that affect more of a meteorologist's perspective are the forecast discussions that they write up. It's always good to see what they're thinking so we can be in line with the same thinking of like, okay, this is how it's going to work out, or maybe they're seeing something a little bit different. Climate products. I've seen changes in this because usually they issue this on a daily basis about 4 or 5 o'clock, and sometimes that's delayed, so that also affects us in terms of, hey, here's the records for such and such a day that come directly from the National Weather Service into our computer system that we haven't been able to use as graphics necessarily. Speaking of graphics, they're also dealing with a graphics limitation as well, just because of the staff that they don't have to necessarily focus on that. This is all temporary as of right now. Hopefully things will change and hopefully they'll get more fully up to staff once we get into severe weather season. Right now, of course, it's quiet, it's summer, but I'm definitely a little concerned as we get closer into the fall season. I want to get more into the upper air observations because it's not just the National Weather Service out of Little Rock that's dealing with changes. What you see here, every blue dot is a station that launches an upper air observation on a daily basis, and that is going to be the local time of 12Z and 0Z. So it's twice a day, each day. This is what's been happening, and it continues to happen across the country. So this is the launches from July 14th, and all the X's are the launches that failed. Now, it could have been weather behind it. It could have been a lack of staff. It could have been other reasons, but you notice there's definitely a cluster through Wyoming, South Dakota, Nebraska, Colorado, and also at this time, Little Rock was not launching 12Z, but also Shreveport and into the Houston area and even Corpus Christi and also Maine. We're going to advance this to another date. This was July 6th, and the story stays the same. It's really this area, Colorado, Nebraska, Wyoming, South Dakota, that the launches are not happening. They said that they wouldn't be doing launches in this part of the country until further notice because of the lack of staffing. This is concerning to meteorologists because if we don't get data in this part of the country and we don't know what's happening, not only the surface necessarily, but what's happening aloft, then the models that take this data into account could miss something. And our weather, of course, usually comes from the western part of the country. It usually comes from Wyoming, Colorado, Nebraska, and makes its way into Arkansas, with that northwest flow especially. So we're missing data, we're missing pieces to this weather puzzle, then that can create a domino effect and lead to forecasts that are not as accurate. Hopefully, again, this is temporary. Hopefully there's something to change this scenario. Maybe there's something better coming out in the future than a weather balloon. It's just a wait and see, but I figured you need to know the truth behind what's happening and how it is affecting us here locally in Arkansas. Thanks for watching WeatherWise. I'm your host, meteorologist Nathan Scott. More new episodes will be coming up over the next several weeks. Until then, have a great day.